This is going to be a comparison of a few pieces of test equipment that I have that can output 10 megahertz. I have a Rubidium Frequency Standard, which is known to be very accurate, and I'm going to use that to compare the others. So I have the Rubidium Standard mounted in this box here, and then I have a Advantest spectrum analyzer. That's got an internal 10 megahertz reference output. And then below that is a Hewlett-Packard 8660D RF signal generator. And I've got two tinySAs just sitting up here by the oscilloscope. Those are economical little handheld spectrum analyzers. And then I've got a Agilent 32120A waveform generator. Okay, here's the inside of the Rubidium Standard. This is the main device here. I believe they came out of old cell towers, and they were very commonly sold on eBay. There's still some on there. The price has gone up. There's power supply for it. And then this LED here comes on. It's hooked up to an output here. So when it's warmed up and stabilized, this light will come on, showing that it's ready to be used, or that it's locked into the frequency. And then I just have a BNC here for the output. Okay, so I have channel 1 hooked up to the Rubidium Frequency Standard, so that's kind of my reference I'm comparing everything to. So I'm triggered on channel 1, that's why that's perfectly stable. And then any variation off of this will be reflected on the other channels. Channel 2 is the Advantest spectrum analyzer, 10 megahertz reference output. And that has a calibration option, so I'm using the Rubidium Standard to basically set this. If I can dial it, the waveform will move left or right depending on which direction. So the goal is that this doesn't move in relation to this. So I've got that set, and now my spectrum analyzer should be fairly accurate as far as using it for a frequency counter. And channel 3 is the tinySA, the one on the left. And you can see that's drifting to the right. So you can kind of gauge the offset frequency from the source by how fast it's drifting. So when each peak crosses a peak up here, if it's once per second, this would be off by 1 hertz, plus or minus depending which way it's drifting. And in this case it's about 2, so this appears to be off by about 2 hertz. And then channel 4 is the 8660D Hewlett-Packard signal generator, which hasn't been calibrated for many years, and that's surprisingly close. And actually, if I dial this in, I'm going to go in 1 hertz above 10 megahertz. So there goes faster. There's 10 megahertz. Now I'll go 1 hertz below 10 megahertz, and it's just drifting the other way. So that's very close, within a hertz. Okay, so on the spectrum analyzer, I've got the counter set up to 1 hertz resolution, and that's right on. And then off to the left here is the adjustment for the calibration of that reference. And just to show what it does here, I'll zoom all the way down to the furthest negative offset, and that puts it about 4 hertz high, 3 to 4 hertz high. And if I go fully the other direction, it's about 3 hertz low. So I'll set this back. I'll go back to the scope here so you can see the waveform. Okay, so the blue trace is the 10 megahertz reference. So right now I've got the spectrum analyzer set to its 0 center point, and it's drifting slightly to the right. So I'll adjust this and see what happens. So I'm going negative now. So I'm probably going the wrong way. It's going faster and faster. So I'll go back up to 0. Now I'm at plus 14. Now it's going to the left a little bit. Here's plus 11, it's going to the right. Plus 12, slightly to the right. And plus 13, it's right on. Just maybe a slight drift to the right. Plus 14 is a slight drift to the left. So I'll go back to 13.